Alright guys, Mr. Bennett here. We're going to look at the next part of the satellite stuff. So I just want to talk in this video about the different types of satellites and what they use for, because that's really important. Obviously it's an application that you need to be aware of. So the first one is a geostationary satellite. Now that refers to a satellite that takes 24 hours to orbit the Earth, and what happens is basically that will be that sort of orbit will be in equatorial orbit, alright? And so what they do, as I showed you with the spreadsheet, these satellites will be along this particular orbit. And if we're thinking about the satellite here, right, it would stay above a certain portion of the Earth, right? So we'll actually have an area of the Earth that it actually stays above. So that allows that. So the geostationary satellite there could be used for telecommunications or anything like that. The big thing about these particular satellites is they're actually a long way away from the Earth, alright? So light travels at 300,000 kilometres a second. It's about 35,000 kilometres. So what happens there is obviously there is a small time delay between the time the signal gets bounced up to the satellite and bounced back to Earth. It's got to travel about 70,000 kilometres, right? So that's a fraction of a second when you start looking at that. Now, obviously, as I said, these have to be equatorial. This thing's actually named after a very famous science fiction author called Arthur C. Clarke. It's called the Clark Belt, all right? And there is lots of satellites on that particular orbit. If you think about the Earth, if they are 35,000 kilometres away from the Earth, and you've got satellites on here, these particular satellites aren't going to be that close together. You could have a lot of satellites up there on that particular orbit, couldn't you? All right, so that's a very useful one. These other ones are low orbiting polar satellites. Okay, so they are a lot closer to the Earth. Obviously, if they're a lot closer to the Earth, then they're going to, when they start looking at your surveillance and all that sort of stuff, they're going to be able to take very good pictures of the Earth. All right, so that's the first thing when you start looking at that. Right, when we start looking at these particular satellites, what happens here is when they go over, they actually sweep a band. All right, so that's, you know, when that satellite's going over there, it's going to take pictures of the Earth quite close to the Earth, and it's going to sweep out a band. So when I start looking at the next time it goes over, right, the Earth will rotate around, and it's going to sweep this band here. So what can happen is you can use computer technology, and that's how you get a satellite picture. Right. So when you start looking at you know, the stuff that you see on TV on the weather, that's a really useful way of actually tracking what's actually happening there. So every time it orbits the Earth, and it might do an orbit every 90 minutes or so it's going to sweep an orbit around there. Now obviously you're not going to just have one satellite doing that, you're going to have a whole heap of satellites doing that. So then you're going to get a way of getting a complete picture of the Earth. Alright, so that's a really useful one. So the benefit of that, when we start talking about the low orbiting satellites, is that they are close. You get high definition pictures. Alright, so they're really useful for there, and they sweep a strip of the Earth. And so in other words, when you start looking at that, you can put an image of the Earth and you can actually look at the cloud cover, or you can... Now the other thing is, I mean, obviously if you're looking at a picture using just a normal camera, probably not so useful, but these particular orbits, these particular satellites can hold infrared cameras, lots of different other cameras that allow you to see beyond the clouds and monitor stuff, alright, so that's really useful. Now, the orbits of a particular satellite can be in any direction. All right, so there is a little pattern though that you need to, and I've seen a question asked about this. So, can we have this type of orbit? And the question is possibly not. Okay, Can we have this type of orbit? Or can we have this type of orbit? Alright, can we have this type of orbit? And the answer is yes. Alright, so what's the difference between this type of orbit and this type of orbit? Well, obviously this one over here, if you think about it, it's actually not orbiting the centre of the Earth. So when a satellite's orbiting the Earth, it has to be orbiting around the centre of the Earth. And it can go in any direction it wants. Alright, so that's really important that you get the concept of a satellite. Now, if you think about one of the most useful parts of using satellites is in fact GPS. Okay, and we probably all use GPS all the time. And that was actually developed by the military, and then they've made that available to the general public. So the GPS allows you to have a network of satellites up in space. These are generally low orbiting satellites. They have a network of them. So what happens is, if you were at a position on the Earth, let's say you were here on the Earth, there might be a satellite that's actually going to be over here. You might use a satellite over there. You might use a satellite over here. Okay, and what it's using is triangulation to actually pinpoint your position here. And these can be quite accurate within a couple of meters. Alright, so obviously when you're looking at high-grade military, they can be accurate as in like inside a meter. And that's really, really useful. You've seen that sort of stuff that they use on bombs. They use GPS tracking and all that sort of stuff to actually deliver a payload on a missile. Alright, so that's actually really useful technology in terms of, even though you might be saying it's could be killing a lot of people, by having the accuracy that they do, they can actually avoid killing a lot of people, a lot of innocent people, by directing the bomb directly towards where it needs to go. Obviously, when you're looking at the issue of travelling around the world, and you know, most of us use our phones and so on to track where we're going to go and find directions, that's certainly a really, really useful thing. I use a GPS thing on my watch, okay, when I'm playing golf. It actually tracks how far I'm out from the hole, so I actually just look at my watch and it tells me how far I've actually got to hit the ball. Awesome technology. Alright, so there's lots of really good applications for that, and you certainly need to be able to talk about some of that stuff, which is useful. The last thing I want to talk about in this video is launching basically a satellite. Alright, so if I want to launch a satellite, there is some benefits of thinking about the Earth and how the Earth rotates to do that. Alright, so if we think about our Earth, we get a lot of our weather coming from Perth. Alright, so obviously rotating there, here's the sun over here. Well, that's a really primary sort of diagram. Okay, so obviously Perth behind us. Okay, so all of our Earth rotates that way. Alright, so the Earth rotates quite quickly, and so when you're thinking about, obviously if you were launching a rocket that way, you've got to overcome the Earth's spin. Alright, so that's actually does take a fair bit of energy to overcome that spin. So what you'd be better to do is to launch it with the Earth's rotation. So that way you get a little bit of an extra boost when you're launching a satellite. Now the other thing is, if we think about the equator, that is the best place to actually launch a rocket from. Alright, so what they've actually done is there's people that actually launch rockets from certainly places, you know, land on the equator, but they're also looking at doing things where you can actually launch rockets from ships and so on the equator. Right, so you can certainly overcome a lot of energy, obviously, to actually launch a satellite. Now, when you're launching a rocket, most of the energy is actually taken up and escaping the Earth's atmosphere. All right, so once you get past that, you know, into basically where you've got no air resistance, you don't need to use so much fuel. So in terms of that, we'll look at that in class, and I'll go through the calculations and the details for that, just to show you how that works. All right. So if you look in your physics application book, you'll see those calculations talked about. But certainly, going with the Earth's rotation and going from closer to the equator will save you a lot of fuel, and that's quite a big saving when you start looking at the cost of launching a rocket or launching satellites into space. All right. So that's an important factor to keep track of. Essentially, with the satellite stuff, you need to be able to talk about the uses of satellites and why they're useful. If I was talking about a geostationary satellite, what wouldn't I use it for? Probably wouldn't use it for surveillance. Why? Obviously, it's a long way away from the Earth, 35,000 kilometres, or nearly 36,000 kilometres away. You're probably not going to get good images. If I was using a low orbiting satellite with a high definition camera on it, I could probably I could get to a position where I'm actually looking at number plates on a car, or even what type of screw they're actually holding the number plate with. All right, so I don't know if you've actually seen the video called Enemy of the State. That's quite scary when you start looking at what they can do with satellites and tracking people and so on. I might show you a quick clip of that in class. All right, so anyway, you need to make sure that you understand and you can talk about all this stuff. So you've got stuff in your textbook, you've got stuff in your application book, a lot about this. What I would be doing is taking and making some notes of key points that I actually need to know. I think that's a really good idea to do. Right, I'll talk to you next time.